So atmospheric pressure can be really big, right? 1 times 10 to the fifth newtons per square meter. That means that if I have a 1 by 1 square meter area, that means that the pressure there is 100,000 newtons per square meter. So overall, there is a force acting on that of 100,000 newtons, right? 100,000 newtons per square meter. That's what that means. So there's 100,000 newtons pushing down on that. Um, However, it's difficult to imagine because the net force is zero. That if I have a person that's just sitting in the atmospheric pressure, that pressure acts here and it also acts here. It acts here and it also acts here. So the net force then, the sum of all the forces due to that pressure are going to be equal to zero because they're all equal in opposite directions. However, we do have some ways to observe it. The first is a barometer. And a barometer looks like this. You have uh, a bowl or some material, some sort of container, and then there's a tube that's inverted, and then within that bowl or that container, you have a liquid. Usually this liquid is mercury, and the very first barometer was actually made out of water. I think they actually used wine in it. So if you imagine this as a barometer filled up with wine, uh, the atmospheric pressure pushes down on the outer parts of this. So this is the pressure due to the atmosphere, and it pushes this column of liquid up by a certain height. You remember that P is equal to rho times G times H. So depending on the pressure will tell you how high this column is. In fact, when we look at our various units, our inches of mercury, our millimeters of mercury, our centimeters of water, all of those refer to the height of that column at different pressures. So for example, atmospheric pressure is 760 millimeters of mercury. You may have seen that as a unit, or you may have seen 760 torr, which is also a millimeter of mercury. So we can use a barometer to measure this pressure, and that's the way that we measure pressure, in fact. The second application, you can really amaze your friends by telling them about this, is a straw. So let's see if I can draw. This is a cup. It has a liquid in it. There is a straw inside of that cup. It's a really big straw, like you get at McDonald's or wherever. And then there's a person. It's a really big cup and a really small person. Let's see, this is always the hard part. With a very large head. All right, so this is a person drinking out of a straw. Um, Now, there is an atmospheric pressure that's pushing down the atmospheric pressure. And then this atmospheric pressure pushes the liquid up into the straw and then up into your mouth where it goes down into your stomach. What you do, I know it seems like you're actually sucking that liquid in through the straw, but really what you're doing is you're just creating a slight low pressure, a pressure that's lower than the atmospheric pressure, which isn't that hard because atmospheric pressure is pretty high. So you're creating a slight low pressure and allowing that atmospheric pressure to push that liquid up into the straw and into your mouth. So it comes up and then it goes in and into your mouth. Um, we'll see an application of this in a video I'll show you where they try to create the longest straw. And so if you imagine that your cup is down here, what is the longest straw that you can have? Well, it turns out the longest straw is dependent upon what is the atmospheric pressure. The longest straw is approximately 10.1 meters because 10.1 meters is atmospheric pressure will cause a column of liquid to be a height of 10.1 meters, right? And the same idea like I have over here in the barometer, that if I have an atmospheric pressure pushing down on my cup into the liquid, it pushes that liquid up into the straw to a height of 10.1 meters. And that is if you have a perfect vacuum, that is in your mouth, that you have a perfect vacuum with the pressure exactly equal to zero. All right, which is very difficult to do. You can't, it's very difficult for a human being to create a pressure equal to zero. I'll show you a video it's a fun rendition of that. And then the third thing is a little experiment you can do at home. Imagine you have a table and you take a sheet of newspaper and you lay it out flat on the table. Now it has to be really, really flat. And then you take a ruler and you put it underneath the newspaper. So it's laying underneath the newspaper. Um, I'll show you a video of this of a kid and his mom trying to do this. But if you do like a karate chop onto the ruler, then it'll cause the ruler to break. You would think that the newspaper would come flying up, but in fact, it'll cause the ruler to break. Or you can do this with a pencil too. I'll show you a video for that. There'll be one in the links for this video. Okay, so those are all good applications and good demonstrations of atmospheric pressure and how we measure it.